Hello students, welcome to lesson 10.1 video. So in this video we are finally going to embark on chapter 10, which dives into this big world of probability and statistics. A little departure from the geometry and algebra we've been doing the last few days, but hopefully it gives you a nice solid introduction to the world of probability and statistics. So let me go ahead and direct you to my screen and let's check out what we are going to actually explore. So chapter 10 is broken up into 5 sections that we're going to explore. There are 7 total with an extension, but we're going to just do the first 5. And in this chapter, the end goal is to get an understanding of how probability is calculated and the general different types of probability: experimental, theoretical. There's these things called compound events, things that you can see showing up here on top of the screen. So the big thing is that this introductory chapter is going to get you a good sound understanding of how to calculate probability, and then as we get further into your math career, you'll see that probability really does open up pretty extensively, especially when you're taking specific statistics and analyzing probability. So with that being said, let's go ahead and go to 10.1. And 10.1, I got the key ideas here, and really the big setup for 10.1 is to get us understanding the language. And it's highlighted here in yellow, but basically we're going to be exploring experimental probability. That's where you actually conduct something. Theoretical is a different version of it. Probability, where it's like if you infinitely do something, theoretically what will happen in whatever situation you're dealing with. For example, a coin. If it's an infinite situation, you would expect that a coin would flip up heads 50% of the time, tails 50% of the time, because there's two. Okay, there's 2 sides to a standard coin. All right, so with that being said, let's look at the other words that are up here. So the big thing is outcomes. We're going to talk a lot about outcomes today. That's what we're going to calculate. It's the possible results of an experiment. So it's what happens, like what can possibly happen when you do something. So flipping a coin, there are 2 outcomes, heads or tails. So what are they? And a collection of all of them, all the outcomes that are possible, is called the actual event. Okay, that'll be language I use a little bit more extensively in the coming sections. But outcome, and then this second word right down here called favorable outcomes, is what we're going to study heavily this chapter or this section. So favorable outcomes is what you want. Okay, so just like that word favorable means, it's what you want in a situation. So if you are gambling and you want heads when flipping a coin, that's the favorable outcome. Now the total number of outcomes is 2 because it's heads or tails. So in the example down below, it kind of gives you a little diagram of the different situations with a marble, or how the words apply, but we're going to explore kind of every type of probability situation that we often study. That's the coin, dice, marbles in a bag, a spinner. So those are the core examples that we're going to try checking out. So let's go and scroll down to example 1, and you're going to see, okay, very standard use of the language. So if you do pretty well in this section, you're going to be fine in the sense that you'll be set up for the language, and that's really the most confusing part about probability. So let's look at this. You roll a number cube, so fancy word for dice. What are the possible outcomes? Well, there are 6, okay? And the possible outcomes are 1, 2, 3, onward to 6. So I'm going to use this kind of set kind of brackets. I know they're not the prettiest looking, but basically there are 6 possible outcomes, and the possible outcomes are 1, 2, 3, 4, 5, 6. Those are the total. For B, what are the favorable outcomes of rolling an even number? So what do we want? Well, we want an even number. So the favorable outcomes is 2, 4, 6. There are 3 possibilities, 2, 4, and 6. And then last but not least, what are the favorable outcomes of rolling a number greater than 5? So we want x to be greater than 5 if we just consider x to be our favorable outcome. Well, there's actually only one number, right? And it's 6. So there's only one favorable outcome. Okay? So one favorable outcome means that in this case it still occurs, but there's not that many of it. All right, so in these situations, I'm not really using any fancy notation, just answering the question appropriately. There will be more appropriate use, like ways of showing this in the next couple sections when we actually calculate probability. But for this first section, just be able to figure out what the outcomes are, what they mean by the favorable outcomes from that, and write it down appropriately. Okay. All right, so let's move on to example 2 and look at a situation that's a little more common, the classic spinner type of situation. So a spinner is a classic probability problem because not only does it give us a lot of very set symmetric parts to it, but okay, when you spin it, it can land pretty much anywhere depending on how you spin it, speed, all that stuff. So there's a lot of randomness. So it says here, how many possible outcomes are there? And this one's a little tricky because when we think outcomes, how many different places can that arrow land? And there are 6 outcomes. Okay. The confusing part about this is that, wait, there are 3 reds. That's not, that does not affect our total outcomes. We don't count it as just one. Because it can land on red 3 times, we still got to count each individual spot as an outcome. So there are 6 total areas. How many ways can spinning red occur? 3 ways. So we can spin it multiple times, but there are still 6 outcomes. And just to be a little bit more set, it's red, 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 because there's 3 of them, then purple, green, blue. And when you list it all, it's a little clearer to see. Yep, there are 6 outcomes. So let's go to C. In how many ways can spinning not purple occur? Okay, this one's a little bit new language, not. It just means opposite. Okay, so how many ways can not purple occur? How many ways can that? It's 5 ways because it can be red, 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 red. There's 3 reds, green and blue. Those are the situations where they're not purple. What are the favorite outcomes of spinning not purple? Well, I just said it. It's red, 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 green, and blue. So this is a great example to show you that even with duplicate colors, we still count them as individual outcomes because we're looking at where that arrow can actually land, and each one is a unique outcome. So this is all the examples that this first section is going to really need. After this, I'm going to move you on to the OYO, so check these out and take a moment to kind of try these. I'm going to try zooming in so you can see everything. There are only 3 situations, so disregard the fact that I got it kind of scattered. There are 3 problems here technically with a multiple part answer. Okay, so take a moment to do this on your own. I'm going to let the video roll for about 8-9 seconds. Then the answer key will pop up. Okay? All right, we're back. So I got the answer key magically pop up on your screen. So in the first situation, pretty standard. Just make sure you know the language. It's asking about even, odd, number greater than 16, choosing a number divisible by 2. So standard things you should know by now. It gets a little bit trickier as you get into the second and third situation. So the second situation, you randomly choose a letter from a hat that contains the letters A through K. There are 11 possible outcomes if you list them. We all know our alphabet. And what are the favorable outcomes of choosing a vowel? There are 3 favorable, A, E, and I. And then the marble situation. So this one, there are duplicate colors just like that second example we looked at, but we count them as outcomes. So how many possible outcomes are there? There are 8, okay, because there are 8 marbles in this situation. How many ways can choosing blue occur? Twice, 2 ways out of that 8. And then how many ways can choosing not yellow? So there's 3 yellow, but we don't count those because it's a not statement. And what are the favorable outcomes? There's blue, blue, green, red, and purple, 5 different ways. All right, so that is section 10.1 in a nutshell. Okay, really focus on the vocab, ensure that you have an understanding of the key concepts there, and then when we get into 10.2, we'll actually dive into calculating these crazy probabilities. So this video concludes here. Feel free to reach out to me via email or whatnot if you have any questions. Thank you for watching.